All right, let's dive into something that's at the very heart of Bitcoin, but honestly, not a lot of people fully get it. We're talking about signatures. We're going to peel back the layers on what you're actually doing, what you're committing to every time you send a transaction. So think about it. You go to authorize a transaction, and it feels pretty straightforward, right? But what are you really locking in? Is it the amount, the destination, the exact coins you're spending? Well, the answer is way more interesting and a whole lot more powerful than you might think. To really get a handle on all the cool, flexible stuff, we've got to start with the default. What happens in just a plain everyday Bitcoin signature? So by default, a Bitcoin signature is a total lockdown. It's like it takes a perfect snapshot of the entire deal, every single input that's funding it and every single output that's getting paid, and it cements the whole thing in place. A great way to think about it is like initialing every single page of a long contract. Once you sign, nothing can be changed, period. Okay, so that rigidity is great for security, but it's not always what you want. And this is where the need for flexibility comes in, and where Bitcoin's programmability really starts to get cool. I mean, what if you want to create a transaction where maybe a friend can add their own funds later? Or what if you want to spend the money, but the final recipient hasn't been decided yet? That standard lock everything model, it just completely falls apart in those scenarios. So how do we fix that? Well, the solution is this simple, absolutely brilliant mechanism that's built right into the signature process itself. Let's get into the SIHASH toolkit. Okay, so this is the key. A SIGHASH flag is just one tiny byte of data. That's it. It gets tacked onto the end of your signature, but that one little byte changes all the rules. It's like leaving a little note for the entire Bitcoin network that says, hey, for this signature, only pay attention to these specific parts of the transaction. You can pretty much ignore the rest. So let's break down the three main flavors. You've got all, which we've been talking about. That's the full contract, everything's locked. Then you have none, which is kind of like signing a blank check. You're committing the funds, but you're not saying where they have to go. And finally, there's single, which is like paying one specific invoice. You lock in your funds and one specific payment, but you leave the door open for other payments to be added to the deal. So just to hammer this home, SIGHASH all is the default. It's the most common, and it gives you that Fort Knox level security. Once you sign, you know for a fact that nobody can mess with where the money's coming from or where it's going. Now, SIGHASH none, this is where we start getting really creative. You commit to spending your inputs, right? So the amount you're spending is locked. But the outputs, they're completely flexible. Somebody else can come along later and decide who gets paid and how much. And SIGHASH Shingle is all about precision. It locks down all the inputs, but for the outputs, it only locks the one that's in the same slot as the input you're signing. So, for example, if you're signing the second input in a transaction, you're only committing to whatever the second output is. All the other outputs can be changed or even deleted. As powerful as those three flags are, there's one more piece to this puzzle. It's a modifier that basically acts like a supercharger for this whole system, and it unlocks a completely new level of collaboration. Let's talk about anyone can pay. Anyone can pay is a total game changer. It's not a standalone flag. You combine it with one of the other three. And its job is simple. It completely flips the script. It tells the network that your signature only covers your specific input. It leaves the front door wide open for other people to come along and add their own inputs to the exact same transaction. And this just shows you how big a difference it makes. A standard SIGHASH all commits to all the inputs and all the outputs. But when you add that anyone can pay modifier, your signature still locks in all the outputs, but now it only commits to your one input. Okay, this is all fascinating theory, but what can you actually do with all this? Let's look at how these flags make some incredibly powerful real-world applications possible. By mixing and matching these flags, you can build some incredible things that would just be flat out impossible otherwise. We're talking about things like trustless crowdfunding, real digital bearer assets, and even services that help clean up the network. So let's walk through a crowdfund. A fundraiser sets a goal. That's the output. Then they chip in a little bit themselves and sign their input with all anyone can pay. Now what does this do? The all part locks the destination of the money, but the anyone can pay part leaves the imports wide open. So now anyone can add their own donation as a new input, sign it, and pass it along until that funding goal is met. It's an incredible way to coordinate funding without needing a middleman. Or how about a bearer check? With SIGHASH none, you can sign a transaction that promises to spend a certain amount of Bitcoin, But since you didn't sign the outputs, whoever is holding that partially signed transaction can just fill in their own address as the recipient and claim the funds. You've just created a true digital bearer asset. Possession of the transaction is ownership of the funds. And here's a really clever one for network efficiency. You use none/anyone can pay to sign away a tiny, almost unspendable amount of Bitcoin, what people call dust. And you don't care where it goes or what other inputs get involved. This lets special services go around and collect all this digital lint from tons of users into one single useful transaction, which helps keep the network a little bit tidier. Pretty cool, huh? So, as you can see, SIGHASH flags already allow for some incredible functionality. But the story is far from over. The development of signature flexibility is very much still happening. There are proposals out there like SIGHASH Any Prevout that are trying to push this even further. This would let you create signatures that don't even commit to which specific coin is being spent, just that it belongs to you. This could dramatically improve second-layer protocols like the Lightning Network, making them way more efficient and robust. And really, that brings us to the big idea here. We've seen that a signature isn't just a simple yes or no. It's a highly programmable instruction. So, if we can define the terms of a financial commitment with this level of precision, what does that unlock for the future of more complex digital agreements, smart contracts, and maybe even totally new kinds of decentralized organizations? It's a powerful question to think about.